According to IBM, every day we create 2.5 quintillion bytes of data, and that 90% of the data in the world today has been created in the last 2 years alone. We're awash in a sea of data and information. And in spite of this, we are awash in falsehoods as well. What can be done about this? Well, the data is out there. Just taking a random example, here's one piece of data from a random site, the World Bank data site. Here, there are hundreds or maybe thousands of CSV files, comma-separated variable files of data. I downloaded one of them, and it looks like this if you open it up in Excel. Looking at this, scrolling down, you see that there's a country code, what this data is about, GDP growth, and then the actual values, which, as you can see at the top, is by year, 1999 through 2019. And this perhaps is a reminder why, in spite of so much data, there is so little information or knowledge or perspective. Who can look at rows and rows of data and make sense of it? No one. Even in Excel, it just looks like gibberish. The only thing that can make sense of data is visualization and transformation of that data into a form that makes sense. How can we do that quickly and easily? What if everyone, or rather those who are interested, could easily modify data that's so available and turn it into useful information that can guide our thinking and our policies? This is where I believe a tool like R is a fantastic opportunity to take all that sea of data and make sense of it. So I'll go through a very simple example here, illustrating the point that what's difficult to understand in Excel is pretty straightforward using a tool like this. Now, to be clear, it is a programming language, and therefore there's a learning curve. But if you get started, you'll find that it's not all that bad. This tool you're seeing here is RStudio. It's an environment in which the R scripting language can be easily used and learned. There's a space for the source code, top left, an area for the data that you are looking at and examining, a place to interactively view items. For example, we can take a look at one of these data items and interactively see the data. You see the years and the GDP numbers right here. And then there's an area for plotting. So let's look at how each step would work. And I'll note here that about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 or so lines of code turns this kind of tabular information into this kind of graphical information. Let's go through that step by step. Step 1 is to import the data. So once you run this command, read CSV, and assign it to a variable, GEP, it reads it in from this file, gepdata.csv. Here's how it looks when it's read into R. Pretty straightforward. There's all the data we saw in the spreadsheet. Still hard to make sense of there. Then we take a subset of that data. I decided it would make sense to look at just the data for one row, the USA line. So I said create a subset where the country code equals USA and only take columns 5 through 23. Going back to the data, we can scroll down. Here's the USA line, United States, USA, GDP growth. There's a whole bunch of numbers by column. I'm going to call this new set of data DF1, just an arbitrary name. So now let's run these two lines. And you will now see that there is a a data frame called DS1, which has USA and all of the numbers for the US. And it's given the first column as country code, C code. Now let's plot that. So I do the plot, and you can see basically what I'm saying is plot these numbers 1999 through 2017 with these values, columns 2 through 20, and a few other parameters. And here's how it looks. It's interesting, nothing terribly impressive, but I can see that the GDP was close to 0 around 2000. It rose up to about 4, then it dropped way down into the negative figures during the market crash, and then it recovered and stayed steady around 2 point something. Now suppose I want to add another country. So what's going on here? DF1 of 2, row 2, columns 2 through 20, is a different subset where country code equals IND. Same formula basically, but a different selection. So when I finish those two steps, I'll have this new 2 rows of data. I have the years across the top, I have the country code on the left, and I could try to plot that. Unfortunately, the built-in plotting routine does not allow more than one, so we'd have to show India and US separately, which is not what I want. So now, how do we show this in a more advanced way? Well, there is a function called ggplot, an advanced library, which allows us to plot the year, the value, and indicate a group code. In this case, the group code is country code, and create a point and a line using that data. But to do that, we have to change the format of the data. The data right now, as you can see, is laid out horizontally, and it needs to be in columns for ggplot to be able to work with it. Now imagine what you would have to do in Excel. In Excel, what you would do is you would copy and paste with a transpose, and that would transpose the data into a vertical format. Here, what you have to do is use a command called melt. So basically, again, we can talk later about how, but when you say melt this data frame using the ID CC code, what's happening is it takes these 2 rows of data, holds the CC code as constant, and then it transposes the data into rows. If we go ahead and run that, what we're now going to have is this slightly altered version of the data, and you can see it's now vertically oriented. It's got USA, India alternating with the years and the values. Now this is ready for plotting using ggplot. So let's go ahead and run that final function. And we have our finished plot. In fact, we can zoom into this, and as you can see, this is much easier to understand what's going on for the variation in GDP growth for the USA in red and India in blue. What I've demonstrated in this simple example is the ease with which, once you learn R, you can use it to manipulate large amounts of data and present it in a variety of different ways. There are hundreds of built-in functions for statistical analysis and hundreds of third-party open source code available that you can freely acquire, install, and use to extend the R environment to do very sophisticated analysis, such as neural networks and association rules and market basket analysis, and so on. So it's a very powerful means that anyone who is interested has to dig into the sea of data on the internet and pull out the information they need without third-party intermediaries and biases. Have fun with it.